Okay, this is lesson 34 for 7th grade, and today we're talking about decimal numbers on the number line. So we have been talking about decimal numbers, kind of rounding them, ordering them, being able to tell which ones were bigger than others, which ones were smaller than others, doing a lot of comparing. We're still going to be doing that, except for now we're going to take a look at them on the number line. So one way that we will see that today is by placing them on a ruler, so say like centimeters, millimeters, meters, meter stick, that type of thing. So our main goals for today here, first of all, we want to understand that between consecutive whole numbers that we can have decimal numbers. So if we think of the term consecutive whole numbers, that sounds a little confusing. It's really not. That just means your numbers that go in order. So let's say between 1 and 2, we want to realize that there can be decimal numbers in between 1 and 2, or say in between 100 and 101, that you can have decimal numbers in between there. So let's say between 2 and 3, you can have numbers like 2.1, 2.5, 2.65, 2.7, that type of thing. So we want to be able to realize that we can have those decimal numbers in between consecutive whole numbers. And with that, we want to be able to label the positions of these numbers on the number line. And also understand the order of those decimal numbers on that number line. So that would also go along with this and being able to correctly label positions. Alright. Also, before I start, I'm sorry that this was up kind of late, but I didn't get to this until after one of my meetings today. So I apologize for that. Alright, to start off here. If the distance between two consecutive whole numbers on a number line is divided by tick marks into 10 equal units, let's stop right there. So between two numbers, two whole numbers, let's say 1 and 2, we're going to put 10 marks in between there. So that would be like 2.1, 2.2, 2.3, 2.4, 2.5. We'd be talking in tenths. Alright? So the numbers corresponding to these marks can be named using decimal numbers with 1 decimal place. So 1 decimal place would be like the numbers I just said. So between 2 and 3, 10 marks would mean 2.1, 2.2, 2.3. Those are all numbers with 1 decimal place, or 1 number to the right of the decimal. Alright, and a way that we can see that normally is with a centimeter ruler, which we've seen quite a bit. Centimeters, well, let's bring it up right here. We have a cutoff ruler here, and we are in centimeters. The little marks are millimeters. This would be 1 centimeter right here. So we have 1 centimeter, 2 centimeters, 3 centimeters, and the little marks are millimeters, and those are, each mark is 1/10 of a centimeter. So this would be 1 millimeter or 1/10 of a centimeter, 2 millimeters or 2/10 of a centimeter. That's kind of how I read it. So this first question here, or example, says to find the length of the segment first in centimeters and then in millimeters. Alright, so let's take a look at it in centimeters first. Well, we're going 1 centimeter, 2 centimeters, and then we're going to go over 3 millimeters. But, so it would be, we're about right there. So 1, 2, 3 millimeters, but that's actually 3/10 of a centimeter. So 2 and 3/10 centimeters, or 2.3 centimeters. Either one of those would work. 3/10, so 3 is in our tenths place, because we are talking about tenths. Alright, now in millimeters. Each one of these is 1 millimeter, remember? So we've got 10 marks per centimeter, so that means we should have, for every whole number centimeter, we should have 10 marks, or 10 millimeters. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every big number will be 10 millimeters. So 10 millimeters, 20 millimeters, 21, 22, 23 millimeters. There we go. So this tells us that a millimeter is a tenth of a centimeter. You can see we just moved our decimal place over once to get down to millimeters. Or we multiplied this number by 10 to get 23. Alright? So that's where those conversions come in handy, which we worked on a couple days ago. Alright, moving on. This basically says the distance between consecutive whole numbers again. We can divide it into bigger amounts of tick marks. So they're saying this time let's do in between two whole numbers 100 equal units. And then the marks on the number line can be named using two decimal places. So for instance, a meter is 100 centimeters. So each centimeter segment on a meter stick is 1/100th of the length of the meter stick. So if we had a meter stick, we know that each centimeter on a meter stick would be 1/100th of that full length of the meter stick. And that's because there are 100 centimeters in a meter. Alright, so as an example, if we had something that was 25 centimeters long, we could also say that it's 0.25 meters long. So let's look at something like this. The perimeter of this rectangle in meters, that's what we're looking for. Find the perimeter of the rectangle in meters. Now the issue that we're going to come and see right away, or at least that we should notice, is they want it in meters, but they have this rectangle in centimeters. So we want to circle that or square it, and we want to make sure that we change those centimeters before we do anything. Technically, we could find the perimeter first and then convert after that, but I'm going to suggest that we always convert before we do any sort of arithmetic, such as adding, subtracting, multiplying, or dividing. Because once we get into area, let's say that they wanted the area of this thing in meters instead of centimeters, it's much easier to get our answer if we convert centimeters to meters first before we do anything. So I'm just going to say convert first before we do anything every time, and we should be in a much better, we'll be in a better boat if we do it that way. It's safer. Alright, so we know that 1 meter, I'm going to write it like this, 1.00 equals 100. Oops, probably want my units in there. 1 meter equals 100 centimeters. So 1 meter equals 100 centimeters, and we want to convert 12 centimeters and 7 centimeters to meters. So we want to turn these into meters. We don't know what they are yet. A couple different ways to do this. We can notice that basically we're just multiplying by 100 to get to this side. That's one thing we could say. Or we're dividing this by 100 to get to this side. So either way you want to do it, if you set it up like this. The other way we could do it is we know that 1 centimeter is 1/100th of a meter, so just take 1/100th times, let's say 12, and that should give us our answer. Either way you look at it, you're basically dividing by 100 to get into meters. So we know that, let's see, we've got 12 centimeters, and we want to get it into meters. Well, what did we do here? Our decimal was here, and we moved it over 2 spots. So let's do that here. 1, 2, 0.12 meters. So this would be 0.12. You would get the same answer if you did it like this. And you can convert any way that you would like. There are a bunch of different ways to do it. So just do it the way you feel most comfortable. Alright, so 7 centimeters. Remember we moved our decimal over 2 spots, so we're going to go 1, 2. So let's see here, we want meters. And 7, so 1, 2. Now we want the perimeter, and all we would have to do at this point is add up all of our sides. And we have to be careful because sometimes students just like to add up the two sides, but this has 4 sides. It's a rectangle, which means this side is the same as this side. And this is the same as the opposite side. Alright, so if we add up all of those, we should get our perimeter. 0.07, 0.07. Alright, we add all this up. 2 plus 2 is 4, plus 7 is 11, plus another 7 is 18. 1, 2, 3. Drop this down. Perimeter is 0.38 meters, or 38 hundredths of a meter. Alright, we're running low on time, so I'm going to speed up a little bit here. And this may be our last example, because we've done my last example on the slides today we've actually covered before, so we'll just make this our last one. So we want to find the numbers on the line indicated by each arrow. So we have a point here at A, a point here at B, and a point here at C. So we want to look at A first, but what we really want to notice is, okay, what kind of numbers are we working with here? Looks like between this big line and this big line, we're going up a tenth. And we don't have a unit, which is okay, but I do know that we're going up by tenths here. 4.0, 4.1, 4.2, 4.3. So we aren't going up by whole numbers here. The 2 whole numbers that are in this are 4.0 and 5.0. So that big gap there that I just pointed out, that's 1. So we have a ton of decimal numbers in between 4 and 5, and there's actually way more than this. We won't get into it, but there are an infinite amount, and it's crazy to think about, but it's awesome. Alright, so what we really want to focus on is, okay, between 4.0 and 4.1, how many tick marks are there? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we know that it can't be bigger than 4.1, but it is going to be bigger than 4.0. So it looks like it's halfway between there. And we can't say that it's 4.5, even though it's 5 over, because 4.5 is right there. So we have to say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these is 10 segments. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we are dealing with hundredths, which means we're going to talk about the hundredths place. So 0 here, 1, 2, 3, 4, 5. That's where the 5 go. That's A. I gotta check my time quick. Alright, we're getting real close there. But yes, 4.05, not 4.5. So let's look at B. Since we're talking in the hundredths place, I know it's at least 4.3, but less than 4.4. So 4.3, 1, 2, 3, 4, 5, 6, 7, 8, 4.38. So at 8 we go in the hundredths place. And our last one here, C, 4.7, it's at least 4.7, but less than 4.8. 1, 2, 3, 4.73. Alright, I'm going to stop it here, and we will work on more of this tomorrow.